Welcome to Learning Module 4c. This is Measuring and Improving Business Process Performance. And I love this L. Einstein quote, everything should be made as simple as possible, but not simpler. And it definitely applies to improving business process performance, because we still have to accomplish what the process was designed to do in the first place. We can't simplify to the point that we no longer are achieving our goal or we went too far. And that can and does happen. So this section, we want to be able to understand some of the concepts and tools that firms rely on to measure and improve their processes. And we want to describe the Six Sigma methodology because it is a global phenomenon and it's laid into firms across sector and around the world. And most students will find when they enter the workforce that they won't have to work in many different firms before they're exposed to Six Sigma. Very important to understand Six Sigma as you enter the workforce. So let's first talk about benchmarking. So benchmarking, it's basically identifying, understanding, adapting outstanding practices from within the organization or outside. There are two main branches to the benchmarking tree. One is the comparison of our processes or products with those of competing organizations. So we might say if we're in the if we're making printers, that we want to compare the way our printer does some particular function to the top competitors or somebody that we know has a technical advantage in that particular product attribute. Or we might look at processes of competitors. Sometimes it's hard to get at competitors' processes. We can usually buy their product and benchmark it, but it's hard sometimes to get at their processes. But nonetheless, we can do competitive benchmarking against competitors' processes where possible. But a lot of times from a process point of view, firms will find it makes more sense to not think of what our competitors are doing, but what the best firms in the world in that particular process are doing. So if we want to know how to improve our payments, we might look at a huge financial institution like American Express or something like this and say, well, we're just a little mid-sized company here, but we want to be the best at this payment process. And we might find that the banks or somebody has really got that knocked, and that we need to think out of the box, not at just making ours a little better like our competitors, but making a quantum leap forward by looking at the very best organizations worldwide in that particular process. So continuous improvement is one approach, very common approach to improving process. And this can be through the bubbling up of great ideas through the workforce, the people that are involved in the process, and it usually is. Or it could be a focused effort to just improve the process, where we get a team together maybe, and could be consultants, people from the outside, but just look at this and say, how can we make some improvements and over time make this a little better? Continuous improvement functions best when we have a stable process. When we don't know what we're doing and we do things differently all the time or in different facilities, different teams do things their own way, it's hard to apply continuous improvement. So for example, if we had 10 different product development teams and the program manager of those teams has a lot of autonomy and we have very different things going on inside of those product development processes, it'd be hard to say we found a great way to do validation testing with our suppliers and apply that across all 10 of those teams, because they're all doing things different in the first place. The foundation isn't stable. So it's important to think of, when we think of continuous improvement, it's important to understand we will have the best success if we first create stability and some standardization at the foundation, and then think of continuous improvement as an ongoing process to be managed. The school of thought that some could say is an alternative to continuous improvement is really a fundamental rethinking, a radical redesign of a business process to get a dramatic improvement. So It's called business process reengineering. Michael Hammer wrote a book and sold 1 million copies, I'm sure. It was a bestseller back in the early 90s called Reengineering. I think it was just called Reengineering. Reengineering your business, whatever it was. And the idea is basically that continuous improvement is insufficient. This is a broken process, or this process is missing so much opportunity that it really doesn't make sense to say, let's fix this a little bit and let's dial that up and get this under control or eliminate this step. It's really about pulling out a clean sheet of paper and saying, what are we trying to accomplish? And let's follow through this continuous improvement, this reengineering methodology and come up with a much, much better entire process. So it's not improving an existing process. It's throwing out the baby, throwing out the bathwater, and getting a clean sheet of paper and saying, let's just take a clean sheet approach to how we do this. We're really broken right now. Okay, and then just the point that reengineering is really heavy blasting. I like to think of a stick of dynamite instead of some measurements and nominal improvements. It's really just throwing a stick of dynamite at it and saying, no, we need to start over with this. So root cause analysis is a very important concept for project teams, quality people, anybody that works in really this world of continuous improvement and quality. The root cause is something we'll hear talked about fairly frequently. What's the root cause? What is the root cause? And we'll try to get to the root cause of things when we're being serious about solving a problem. So the first thing that often happens intuitively is when we have a problem is we look at symptoms and we put temporary measures in place to solve the problem temporarily. To say, well, we dropped something on the floor, it made a mess. Well, we cleaned the mess up, right? We picked up the pieces and threw it in the garbage, and now the floor is clean again. So we've taken care of that. That's just treating symptoms, right? So root cause analysis is something that all business people should be adept and understand the concepts of. It's basically a way to brainstorm and try to get deeper into the problem to figure out why. And sometimes we'll hear the Toyota 5 why approach of saying, why did the plate drop on the floor? Because it was wet and slippery, and I could only use one hand because I had something else in my other hand, and I bumped into somebody and then it flew. Well, why did those things happen, right? So you could say, well, why was your hand all wet? Well, I did it while I was doing the dishes, and there were people around, and I bumped into them. Okay, well, why did you move the plate from way over there while you were doing the dishes? Because I didn't collect everything all ahead of time. I just picked things up all over the kitchen while I'm doing the dishes. Well, why do you do that? Because I don't have a good plan. I should create a sequence where all that stuff is gathered and put by the sink before I start the dishes. Okay, it's a crazy example, but you get the idea. You can say why, and try to get down deeper into a causal factor. The interesting thing to understand about those causal factors is that there's usually more than one. So we say, what's the root cause? But when we really get into these exercises, there's usually a number of causes that can coexist quietly until something triggers the problem. So it's not necessary to come to a single root cause. We can talk about multiple root causes, and an example that's sometimes used to describe that is if we have a fire, we could say, well, we had to have oxygen present, we had to have fuel to burn, we had to have an ignition source, right? Or we wouldn't have had the fire. So we could stop and just say, well, somebody lit a match, so we have a fire. Oh, nobody should have lit that match. And, let's figure out why the match was lit, and we could just solve that. But we also could look into those sources of the flame with the fuel and the oxygen and so forth, and we could deal with those in certain circumstances. The oxygen would be very hard to deal with, but the fuel would not. So we could say, why was the gas stored where it was stored? Is it necessary to put it there? Can we work on that as well? So we can get down to, sometimes a single root cause, but more often we'll find a number of contributing causes that might have been lying latent until that match was struck, right? So there could be more ways to solve the problem permanently, permanent corrective actions, than a single root cause. A common tool used for root cause analysis, unfortunately, has at least 3 different names, but I would definitely want students to understand those names. So a cause and effect diagram is also, because of its shape, very often referred to as a fishbone diagram. You can see the shape there in front of you. And its founder, Ishikawa. So if you're talking to a lean team, they might say, let's do an Ishikawa. If you're talking to another group that's not into the Japanese language and interpretation of that, they might say, let's do a fishbone. Very common to call it an Ishikawa or a fishbone. But you can see by the ribs on the fish that basically there are causes, these multiple causes, as I mentioned, that we explore. And what happens is we'll build out those ribs with smaller items, right? So under manpower, if the problem were, related to quality, let's say, under manpower, we might put new employee training, cross-training existing staff. So for example, a couple of things, right, that are training related. It could be anything under manpower. Methods, what are the different things that happened here at a tighter level where we're getting closer to root cause. So we can build the bones onto the bones, right, to explore deeper into this root cause. And at the end of the arrow is the effect. The effect was the problem, right, that we wanted to attack that day. So some tools used in root cause, 5 whys we talked about. Why is this a cause of the original problem? And you can go through the loops. And it's called 5 why because some observers noticed a lot of times it takes 5. It might take 10. It might take 3, right? But 5 whys is a way to make that point, to keep digging and asking until you feel comfortable that you've gotten to the root cause. Scatter plots, we're going to take a look at an example. It's a graphic relationship between 2 variables, an x and a y. And check sheet, it just, could be how often does something occur. That could be sitting at the side of a line and somebody just, checking it off. Yep, it happened again. Pareto chart is a graphical form of maybe what that check sheet could become that shows how frequently and weights different causes or effects. Puts a weight to them so we can see it easily. So here's a scatter plot, and we can see in this scatter plot the defect rate in percentages up one side, and then the overtime hours per week on another side. Okay, so we have defects, a relationship between defects and overtime shown through that scatter plot. The checklist, as I mentioned, we could just look at frequency over here and look at this as a simple list to say, how often are different things we're measuring happening here with these process. Here's a Pareto chart. Very often companies use Pareto charts in their continuous improvement. The Pareto chart allows us to say, let's prioritize the number 1 or the number 1 through 3 items and not try to do everything, which is always very useful. When we try to do everything, we do nothing, right? So instead of spreading all our effort across a huge volume of items, a Pareto chart can let us say, look, let's focus on the top 2. It probably will follow the 80-20 principle, right? The Pareto is the founder of the 80-20 principle, saying 80% of our problems come from 20% of the things that go wrong. And so if we just focus on price check and override here, using the Pareto principle, the 80-20 principle, then we'll solve a majority of the problems here. So important to know what a Pareto chart is. And again, it's just a graphical representation to easily let us see where to focus. Where's the biggest concerns, and not treat everything equally. Here's a run chart. So customer complaints spread across time. Basically, simple graphical representation that tracks changes in a key measure over time. Here's a bar graph. Bar graphs are graphical representation of data that puts things into categories. So if we have an A, B, C, D, E, F, right, and just distribute what's going on with grades right there, right, in a classroom. Bar graphs are an easy way to see those things. Histogram is a special form of bar chart that tracks the number of observations within a certain interval. All right, so we can check with a histogram history. Within certain intervals, we can see how often different things happened. So let's talk about Six Sigma. Six Sigma is based on total quality management principles, and we'll look into TQM a little bit deeper in another module in the course. But TQM is basically the permeation of quality practices throughout the organization, led by senior management, and showing a way for the company, a methodology, a deliberate methodology to improve quality of the organization in all the key areas that drive quality. Six Sigma adopts those principles. It's a system for achieving, sustaining, maximizing business success by minimizing defects and variation. It's entirely focused on process. The name Six Sigma refers to the variation that exists within plus or minus 6 standard deviations of the mean process output, which is 3.4 defects per million. So if we're operating at a Six Sigma level of quality, level of variation, we are achieving 3.4 defects per million events on an overall basis, which is a very high level of quality. For most manufacturing organizations, that is a fantastic goal and represents really competitive advantage. In some, as we'll see in a moment here, in some businesses, it's not good enough. So we'll talk about that a little bit. It was originally developed by Motorola, and then it became popularized by General Electric for the service industries. GE put Six Sigma on the map. Jack Welch was CEO of the year, and GE was really regarded as the best managed corporation in the world for many years under his leadership. And he was very process oriented. He saw this Six Sigma tool, and he took it hook, line, and sinker and drove it through all of GE's divisions, all of their manufacturing operations, all of their administration centers, and said, we're going to be the best in the world at process. If we're great at process, we'll have the best value for our customers and the best quality. So some more on Six Sigma here. It's a business improvement methodology, and it's important to understand that. I underline that word because I want you to realize that while we have some Kaizen and lean and continuous improvement concepts that we've talked about, Six Sigma is a way for organizations to take a package, a methodology, and just apply it. There's consultants and books and papers written on this is how you organize a Six Sigma organization. This is how it functions. We can train you. We can get you up and running. You don't have to create it. So it's one of the beauties of Six Sigma is that it's really institutionalized as a methodology. It requires that we understand and manage key customer requirements, that it's built around the idea that the process must serve the customer and make the customer delight. It aligns key business processes to achieve those requirements. So the customer comes first in Six Sigma, and we don't lose sight of what the customer needs. It uses a rigorous data analysis, really just based on some fairly light statistics, to understand and ultimately minimize variation in those processes. So if we say it's an internal customer, then what delights that internal customer out of this process output? If it's an external, same idea. What delights that customer out of this process output? And then how can we organize that process to basically center the mean So we always have process outputs that can drift to the right or the left of where we designed them and where we want them. So let's say we want 100 pieces per hour as one of the outputs of this process. Well, we could be getting 110 or 90 sometimes. So we want to center the mean. If it's a measurement and we want 1 millimeter diameter hole, but we're drifting between 1.1 and 0.9, we want to center the mean and get as close as we can to that 1 millimeter size. So centering the output and then reducing any variation in that once it's centered. So it means if we had variation that was running from, let's take that one centimeter hole, right, or a certain size, a certain location, right. So if we were drifting right and left, that's one quality issue of the process. We're moving off the center of where that hole needs to be located. We want to center on it. If our hole is growing larger and smaller, that is variation, right? So we want to center the mean and center that hole where it's supposed to be located, not let it drift around, and we want to get the size of the hole exactly focused within a tight constraint on where it should be. That's how we would achieve Six Sigma, is to center the mean and reduce the variation. So driving rapid and sustainable improvement of the business is definitely part of Six Sigma. And companies that apply it and really commit and do well at it deploy projects, and they tend to be some low-hanging fruit where they really make some money in the beginning. And then we move on to the next level, the B's and the C projects. Okay, so DMAIC is define, measure, analyze, improve, control, and it is the standard major process gateway of Six Sigma itself. So define is basically when a team gets together and says, what is the project's purpose, its scope, its outputs, the requirements of the customer and what the customer values and so forth. And then measurement. So we go into a data collection phase. So we've defined what we need to do, and now we go get the data. We don't say we have opinions about the data. We get the data, all right? Nothing can substitute for the data itself in a Six Sigma project. We analyze that data, and we look at the repeatability, the reliability, the reproducibility of the data. Can it be trusted? And then we make our improvement. So we'll design a new step or stages or the way we approach this thing. It's going to be a process improvement, and we'll implement that, and then we'll control. So we'll basically go back and check that from time to time and say how did it work and so forth. And it's a circle, because we can finish one project on an assembly line in an accounting department and purchasing, wherever we are. We can finish one project and then we go to the next one. We might go right back into the same process and do another Six Sigma project. All right, so it's a methodology that's structured, that's proven to work, and it relies on this DMAIC. You should remember that for an exam in the course, that these steps are absolutely defined for the Six Sigma process. So just to give you a feel for the scale of where companies are, where this drives for firms in their overall quality, we've got the Sigma, the Greek Sigma letter over here, and this is 2, 3, 4, 5, and 6 Sigma levels of process capability. So if we're at 2 Sigma, we have 308,537 defects per million. What does that mean? A little bit over 30% defective. Pretty horrible, right? If we're at 3 or 4 Sigma, we've got 6% or 6% or 0.6% defects per million, which are also difficult. But a lot of firms operate in that 4 Sigma area of quality, around 0.5% or so defects. And they pay a price for it, but sometimes it's as good as we can get, because there's so many variables going on that are causing the quality issue, or because the quality requirement is so difficult to achieve, that it does happen, and it's fairly common to operate in a 4 sigma range of quality. But you can see how this drops off statistically. As we get into 5 and 6 sigma, we're really reaching for perfection. At 6 sigma, we're bumping on perfect quality. We're bumping, we're knocking at the door. But it is important, and I'll just mention it in this slide, and we'll talk about it more when we get into lean, that 6 sigma is insufficient for some industries. So the airline industry would never say 6 sigma is good enough because it's lives on the line, life and death. The pharmaceutical industry would never say that 6 sigma is good enough because, again, it's people's lives on the line. So there are industries that don't say their goal is 6 sigma, it's higher. But for most manufacturing firms and process firms, 6 sigma is a beautiful and very difficult goal to achieve. There are certain defined roles in 6 sigma. This is our last slide, but I want you to be aware that along with the structured process and methodology, we also have certain roles. So when 6 sigma comes to an organization, there's usually somebody at the top has brought it in, maybe the vice president of quality or the vice president of operations or the CEO themselves, somebody that's tied into the process orientation of the business has brought it in and sold it to the management team, and it's deployed with very specific roles. So people have to be trained and have to go through a few projects to achieve any of these 3 credentials: master black belt, and green belt. So what will usually happen is a consultant will come in and train a broad group of people in being a team member. How do you participate in a 6 sigma project? And train people with some authority in the organization how to be a champion, because every project has a champion to help them get through roadblocks. Right? So the project team is working over here, and every now and then they report over to the champion and say, how's it going? How's the progress? Are you getting the cooperation you need? Are you getting your data? Have we put in the new process and so forth? So the champion is there to help get through roadblocks and help the team move forward. The team members have to have a basic understanding of the DMAIC process, or they're going to flounder in the meeting. They'll be trying to recreate the wheel and say, why don't we do this way, and why do we do that way? And there's a structure, and 6 sigma tends to work very well in its structure and get people past the let's figure out how to do the process phase and into the work. These 3 roles are very active and are really a progressive level. So the green belt is able to run a 6 sigma project, and they've gotten their green belt by running 2 6 sigma projects and having them successful, and then they get their green belt. They know the methodology. They've used it twice successfully. Black belts are trained at a much higher level, and they're sometimes it's not always a full-time job, but a company will usually have several, at least, black belts that are just able to really nurture the green belts, support the green belts, lead complicated, difficult projects. And the master black belt is a full-time 6 sigma expert with even more training than the black belt. So these are the tools for the green belt. The actual tools of how to run a project, all these folks have. But the black belt and the master black belt have more advanced training in how to overcome problems and the managerial side of getting through projects, difficulties in valuing the projects and so forth. So it's really just a level of training and a level of how much time commitment that they give. The green belt could be a person just working in a department that runs 1 or 2 projects a year. Black belts do more projects, spend more time on it. Master black belt, full-time. That's their job. In summary, for this section, business processes are measured and improved to improve the firm performance. We are as good as our processes. And benchmarking is one way to provide a comparison, and we can do that with best-in-class process performers. We can do that with our competitors, right? So remember the difference, competitive benchmarking and process benchmarking. Continuous improvement provides small, frequent improvements and is really should be in the DNA of any great organization to just find ways to change, get past that resistance to change, and be willing and eager to do things better today than we did yesterday. Re-engineering is when that is not sufficient, and we need to get out the stick of dynamite and stop that process and install a completely new, much superior process. Root cause analysis is critical to avoid mistakes in process. We can think of the Toyota 5Y, and remember that it's okay to have multiple root causes. Usually there are multiple root causes that have been lying latent, as I said, waiting for that match to go off. But it wasn't just the lighting of the match, it's also that the fuel was stored there in the first place. Let's take care of both of those. Employee training might also be a root cause there, right? So we can use the Ishikawa diagram, the root cause diagram, the cause and effect diagram, the fishbone, right? So remember that Ishikawa diagram is about root cause analysis, and I'm sure you'll build some out in your careers. Six Sigma is a structured approach, methodology to systematically reduce process variation and improve customer satisfaction and financial performance by targeting 3.4 defects per million or less. That concludes this section. I hope you've enjoyed it. It's important whether you're in manufacturing or marketing or accounting and finance, purchasing, engineering. These process discussions are important to anybody in business. And that concludes our session.